Hello. Okay. As long as the stream seems like it's in good health, and right now it does. I ran a little private stream earlier, and it seemed like the connection was fine. So we're going to make an attempt. If it fails, then back to the drawing board. Okay. So today we're going to talk about loops, really for loops and lists in Python. So the reason why I've kind of, it used to be two separate topics, but I've combined them into one topic, and really the reason that I've done this is because for loops are mainly used on lists, and lists are used in order to scan through a list, or in order to add things to a list, or in order to basically do anything with a list. You're going to probably use a for loop. I mean, you can also use a while loop, but that's not this week. So basically, I think they're kind of a simple topic, or single topic, and so I've kind of unified them. So, all right. So I think the only reason why I really brought up Inkscape here is because I want to talk about control flow, which is, it's a silly little side thing, but it's a bit of terminology that you might hear later on in your computer science career, or maybe even now, about how programs work, right? So Python has basically a few different ways to control the flow of a program. One is the sequential flow, or whatever. Yeah, I actually haven't been able to switch yet, so Comcast isn't throttling me today. Yeah, so control flow. So sequential control flow is basically one line of code executes, and then the next line of code executes, so on and so forth. Right? So that's sequential. And sequential, you might think, well, like, isn't that how all code works? But then when you think about it, conditional control flow works slightly differently, right? So conditional works by, it tests a line of code, and then it either jumps over or allows execution of a block inside of the condition. So you know how if you write an if statement, if something, and then you have do something in here, then this do something only executes if the first something is true. Well, my condition. So it only executes if my condition is true, right? If my condition isn't true, then either it goes to maybe an else clause where we do something else, or alternatively, it could just jump over the if statement. So if statements they don't execute exactly one after the other, because once this line of code is finished executing, it doesn't always execute this line. It sometimes executes this line. If the else isn't there, sometimes it just jumps over it. So that's why conditional control flow is a different thing than sequential. And then today we're going to be talking, this is like the only bit of theory we're going to do today, but I just kind of should mention it because it's iteration. So iteration is basically, instead of testing a line of code and either executing a block or not executing a block, iteration is when a block of code is repeated, either, right, while counting through an array, or while, what should I say, or while a condition is true. So basically the difference between conditional and iteration is that in a conditional statement, in this if statement, this do something only executes once, and this else would only execute once if that executes. So one of these will happen, only happens once. But today we're going to talk about loops, for loops, which give us iteration ability. And so when I say the word iteration, what I mean, so iterate or iteration, that basically is synonymous with looping. So if I say iterate, that means you want to go through a list or you want to do a piece of code multiple times. Iteration is the, what are you doing while you are iterating? You are engaging in iteration. So that's what the terminology is. And so with that, let's begin. So just memorize these three terms. It's very rare that I'm going to ask you to memorize terms in this class, but this is definitely something that the reason why we teach it in 201 is because maybe when you get to 331, maybe if you do any compiler ideas, maybe sometime like that, if you're ever talking about computer science theory, you might hear the term control flow, and this is what they mean, so I want to talk about it. Do we need to put def main? So I don't know what def main is. I've never talked about it, and I won't talk about it. Okay, we might talk about if name equals main, right? So maybe I'll talk about that a little bit today. But previous semesters used the def main. Def main, that's when we get to functions, so let's not jump ahead. Okay, so I want to start today talking about, let's start with for loops. So I always have the decision of whether to start with for loops or lists. In this case, I'm going to start with for loops for no particular reason. So basically, a for loop is a way to execute code multiple times. So for instance, let's say that we want to print out something 5 times. The way to do that is you say for I in range 5, and I'll explain what all this means in just a second. The colon has to be there at the end, so you use the for keyword. I is the index variable. In allows iteration through the range 5 object. And I'll explain what range 5 is in a bit. Right? TBE, I guess. Okay, so if I do something like for I in range 5, then I print out, for instance, hello there, right? Then I run this program. What you'll see is that hello there gets printed out 5 times. So why did that happen, right? And what is this range 5 object? So let's think about what's going on here. So what the for loop does is it says for I in range 5. So it says take the first thing in this range 5 object. Well, that's a good question. So I think what we should do here is we're going to print out I to see what happens, right? I mean, are we computer scientists or are we people who are not computer scientists? So if we're computer scientists, then I is going to start out at 0. And if we're not computer scientists, then it'll start out at 1. So let's see what happens. Okay, so as it turns out, we're computer scientists. So here it's saying, hello there 0, hello there 1, hello there 2, hello there 3, and hello there 4. So why does it start out at 0? We'll get to that when we talk about lists. So the point is that range 5 gives us 0, 1, 2, 3, and 4. So it starts out at 0, and it goes up 5. So if you count from 0 and up, it takes 5 steps to reach 4. So if you try it, you say 0, and then 1, and then 2, and then 3, and then 4, and then you counted up all of your 5 fingers. So you notice that this actually counts up to 5. So what range does is it starts out at 0, range at n starts at 0, and gives us each integer up to n minus 1. Or I should say up to n, but not including n. Right? Or up to and including n minus 1. So it's shifted a little bit, right? It's shifted a little bit, but at least it still gives us 5 things, right? So that's the whole point there. So, okay, what other kinds of things can we do with a for loop? So let's do an example. Let's say that let's say n is equal to input, enter an integer, right? And what we're going to do is we're going to go for I in range n, and then what we're going to do is we're going to add up all the integers up to n. So if we add up, for instance, if we add up all the integers less than n, so what we're going to do, well, less than, or n, but also bigger, So, okay, so what we're going to do is we need basically a total, and we're going to say total is equal to total plus I. So the first question is why we don't do total equals total plus n. We don't do, like, for instance, total plus equals n. Why is that not right? And the reason is because n, after we enter this loop, n is fixed here. So this range n object is dependent on n, but n doesn't change. The thing that changes is I, right? So what this is going to do, for instance, if we put in, say, n is equal to 5, it's going to add up 0 plus 1 plus 2 plus 3 plus 4, which actually, as it turns out, is equal to 10. And if we do, for instance, n is equal to 6, we're going to get 0 plus 1 plus 2 plus 3 plus 4 plus 5, which is 15, etc. So, okay. So there's an issue here with this piece of code. We can't run this as is. There's one thing we have to do before we embark on our little loop. And if we ran this right now, we would actually get an error. Let's see, 5. So here we get the error. It says total is not defined. This is one of the most common things that will end up happening to you when you're starting out doing this stuff. You'll define a total variable, but then you'll think to yourself, hey, wait, total never actually gets defined the first time, right? So here it's okay to say total equals total plus I, but the problem is on the other side here. This is the problem, because the first time you go through this loop, total doesn't exist. And when total doesn't exist and you try to set something equal to a variable that doesn't exist plus I, you're just going to get does not exist. So, does not exist in Python is a name error. So in order to do this, we need to initialize the variable. So we need to initialize the variable. Let's do that. So we say total equals 0. And then we can say print total, right? Maybe even the total is. Something like that. Okay, so let's do, there's a bunch of hellos. So now let's do 100. And so I think 100 is going to be 99 times 100 divided by 2, which is 50 times 99. So what is that? 4,950 or something? Am I right? Or am I crazy? Yeah. I'm right. Thank goodness. Yeah, so the point here is that we've just added up all the numbers starting at 0, right? So remember, we've started at 0, gone up to for instance 99, right, or whatever n is. We've added them all together, right? So this is what's something called the Gauss sum, or at least I call it a Gauss sum. So okay, so that's a good first example of a loop. All right. What other kinds of things can we do with loops before we get to lists? Let's go through and let's output all the numbers. So remember, you can put other code inside of a for loop. So for instance, if say okay, so or I don't know. Let's make it or. I is divisible by 7, 3 or 7. And I guess we can actually just use I, right? We could do something like this. So I just made this condition up at random. I know that I'm doing a lot of math examples. The reason why I'm doing math examples is because right now all we have is the range object, which does, yeah, basically this is like a fizz-buzz kind of coding question. But the point is that, I mean, I just made this up kind of at random. So what's going to happen is that it's going to go through 0 to 99, and it's going to ask for each one. Are you divisible by 7, or are you divisible by 3? If it is, it'll print it out. Otherwise, it won't do anything, right? So let's see what happens. Let's put in 21 here. Okay, cool. So let's see what we got. So 0 is divisible by 3 or 7 because it's divisible by everything. 3, 6, 7, 9, 12, 14, yep, 15, 18, 21, 24, yep. And so you notice that we're not getting like 29, for instance. We're not getting 31, 32, 34 is missing, etc. So the reason why it's printing out some of them but not others is because it's only printing anything out when you can divide either by, for instance, like 75 is divisible by 3, 77 is divisible by 7, 78, I guess, is divisible by 3, because it's 60 plus 18. 81 is divisible by 3. 84, I guess, would be divisible by 3 again. 3 again, 3 again. This one can't be divisible by 3, right? Because this one's divisible by 3, and this is 1 off from it. So it has to be 1 mod 3, so this is divisible by 7, etc., etc., right? So this is 70 plus 21, so that would be 13 when you divide by 3. Or 7, I'm sorry. So the point is that, yeah, that's what we do. Okay. So, but you might be saying at this point, okay, that's a lot of pointless, like, number crunching gibberish, right? So what if, to remember, say, 5 different words, right? So what we can do is we can create a list. So in order to remember things, you need to have a list of objects. So let me show you how to declare a list. So to declare a list, use the brackets notation. And so, for instance, here's how to do it. My first list equals, there we go, and that's a list. So, okay. So let's say we want to input 5 words. We can do for I in range 5, and then we can do the first real function that you're going to be officially taught in this course, which is append. So the first thing we'll do is we'll say word equals input, tell me a word, right? and then we will append it. So what does append mean? Append means add it to the end of this list. So at the end, we're just going to print out the list, and we'll see what happens. Okay, so here's our first experiment with lists. So a list is a type of variable, right? But it's not actually an int, right? It's not an int, it's not a float, it's not a bool, it's not a string, it's a something else, right? What it is it's a collection of different variables. It's basically a collection of different slots in which you can put other variables. So for instance, let's just do this example and see what happens. That's right. Enter an integer, 44, who cares? Okay, tell me a word. Happy, robot, antique, and oxygen. Okay, so what comes out of this thing, right? What comes out of this thing is this kind of, it looks like this when it prints out. And so you'll notice that it'll say happy, robot, antique, daffodil, oxygen. So, okay. All right, fine. So we've made a list, right? But how do we access a list? Like most of the time, you're not going to want to access all of the elements like this. You're not going to want to simply like spit out everything at once. You want to access one element at a time, right? You want one element at a time. And so the good news is that there is something called a for each loop. And a for each loop is a specific kind of for loop where you say for word, or say let's use a different variable, my string in my first list. And what we can do is print out my string like this. So let's look and see. So enter an integer, or 20, whoa. So almost had a little type error, value error, I guess. So tell me a word. Cautious, portal, fire, train, main, I guess. Train main. So, okay. So the first thing that happens is that we print out the whole list as one object, right? That's what happens when you print out the whole list as one object. And now here, what's happening is that this is a for loop that's scanning through the list. And so it's scanning through it in order. And it's printing out the first thing, the second thing, the third thing, the fourth thing, and the fifth thing. Or technically, if we're being more official, it's printing out the 0th thing, the first thing, second thing, third thing, fourth thing. And so you see that it's printing out one thing at a time. And that's usually this is usually what you want, because most of the time you're going to be operating on whatever the data elements are inside of a list. You're not going to be printing out a whole list. You'll probably want to print out 1 or 2 elements from a list. So basically, this is how to access. If you just want to access every element in a list, this is how to do it. For instance, let's say that we want to get all the words that start with A. Well, we don't know how to do that yet, so let me teach you. So we want to get all the words that start with the letter A. And so you know how to get a string out of a list, and you do it like this. But how do we get a single character out of a word, out of a string? And so the way to do that is to access it. And you access it using the index brackets like this. So what this is going to do, let me just show you how I would do this. If my word 0 is equal to A, then print my word starts with A. So let's see this in action. Let's get rid of all this other stuff here for now. Let's just do if false. There we go. So tell me a word. Word. Bird. Absurd. Curd. Blurred. Okay. I'm glad I accidentally picked one that started with A, because otherwise that would have been stupid. So, basically what's happening here is, yeah. Well, so here it's printing, because we've printed out the whole list, it's still doing that. Because we're still printing out everything in the list, it does that. But then finally it goes through the new piece of code that we've written. For each word in my list, or my first list, so for word in my first list, so if the 0th element, and so let's talk a little bit about what this is doing. So my word is a string, which is basically and each string is a list of, let's not say it's a list, it's a collection of characters. To get the character at position I, you access it like this, right? My word at I. Okay? The thing that you have to be careful of is I needs to be less than or equal to, or less than specifically, needs to be bigger than or equal to 0, and less than the length of my word. Now, technically, there's negative indices, but I haven't said anything about those yet. So let's stick with positive indices right now. So be careful. Right now, you should just have 0 is less than or equal to I is less than the length of my word. So that's something that you need. So we can always access, say, the 4th letter of a word. But the problem is that we don't necessarily know that there will be one. Technically, we don't even know that there will be a 0th thing. We can cause bugs. This can cause bugs. So in order to get the length of a list, or the length of a string, length of a list or string, use the len keyword. It's less a keyword than it is a built-in function. I guess that's technically what it is. So what it does is, like, if I print out the length of my first list, that will print out the length of that as a list. If we print out the length of, say, robot attack, let's see what happens. So let's think of words. Words are going to be ASDF, 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 ASDF. So ASDF starts with A, but really we don't care. We just want to do the length stuff. So here, the length of my first list is 5, right? So that's why 5 comes out here. And the length of robot attack. Let's count the length of robot attack. So that's 1, 2, 3, 4, 5. And remember, spaces count, so that's 6, 7, 8, 9, 10, 11, 12, which matches with 12, right? So the good news is that this will tell you the length of a string, and this will tell you the length of a list. So you can use len on both length of string and length of list, so that's good. Okay. So, okay, let's do an example where, say, we want to access a list in reverse order, maybe. Not a bad example. And it'll get us thinking about indices a little bit. So for instance, let's say that our list is equal to A, B, well, actually, you know what, we can just, okay, so we can just put in A, B, C, D, E into the word list. So how do we access things in reverse order? So in order to access them in reverse order, we can't do a for each loop, right? We cannot just scan through, because a for each loop is only going to go, only going forward through the list. So we can't access it with that. So what we need is what's called a for I loop, which is the other type of for loop. And we distinguish them in this class. Python doesn't actually distinguish them, but we do. And the reason why we distinguish them is because for I loops, we should say really for index loops, right? Like, we don't care what the actual variable is here. What we care is that it's counting an index. So for instance, if we do something like for I in, and this is the general format, in range of the length of the list, so my first list. So this is the format of a for I loop in general. So we've learned about length, so that'll get us the length of a list. And we've learned about range. Range takes a number, and it gives us 0 to that number. So length gives us, and then range of x will, let's say, the range of L gives us indices starting at 0 and ending at x, or I guess L minus 1, right? So that's what the range does. So basically, this is not giving us elements out of the list anymore. If we print out these i's, let's just put in A, B, C, D, E, I guess, right? What you see here is that this is not giving us letters anymore, right? If we print it out here, for instance, if we print out the strings inside of my first list, that'll give us the A, B, C, D, E stuff from this list. But if we print out the indices, right, this is giving us indices, it prints out 0, 1, 2, 3, 4. So, basically, if you want to access all the stuff in this list, this is how you can do it. You can say, my first list at I. So this will access it not in reverse order, but in the forward order. So not in reverse. Yep, this is forward order. Let's see what happens. So A, B, C, D, E. And so here you see that 0 corresponds with A, 1 corresponds with B, 2 with C, 3 with D, and 4 with E. The reason why is because this is the 0th element of this list, this is the first element of the list, second element of the list, the third element of the list, and the fourth element of the list. So that's why this happens. Okay, and so last example before we actually do the reversing thing. If I print out, for instance, my first list at 3, and then my first list at, say, 1, my first list at 0, my first list at 4, etc. So I didn't print out 2, but who cares? So let's put in A, B, C, D, E again. And so what is this going to give us, right? So remember that it starts off at 0, so this one's going to give us A, this one's going to give us B, 2 would give us C, 3 gives us D, and 4 gives us E, right? So that's how you have to count these indices, right? So when you count the indices, basically the way to do it is if you have 0, 1, 2, 3, 4, maybe let's put some things in the middle, here we go, and then like this, and then so this is the index, and this is the element. A, B, C, D, E. So that's what's going on inside of this list. So, okay. let's hit enter and see what happens. It should be DBAE, right? DBAE, I think. Right, so this prints out D because this is accessing the thing at the position 3, B because it's accessing the thing at position 1, A because it's accessing the thing at position 0, and E because it's accessing the thing at position 4. So, yep, okay, there you go. That's how to do it. So let's reverse. So now we've talked about indices a little bit. We've talked about for I and for each, and our goal here is to reverse this list. So let's reverse the list, or at least print it in reversed order. Print list in reverse order. So there's two ways to do this using range, and I'll show you one way that's kind of, well, okay, I'll show you both ways, but I'll show you the way that we currently could figure out first. So for instance, what we're going to do is do a for I in range len my first list, like this. And why is it unhappy? Unresolved reference. Oh, because I didn't type in. There we go. Cool. So what I'm going to do is let's calculate. So if we want to reverse the list, when I give it 0, I actually want 4 to come out. When I give it 1, I want 3 to come out. When I give it 2, I want 2 to come out. When I give it 3, I want 1 to come out, etc. So I basically want them all to flip. So how do I do that? So let me show you a way to do that. One way to do that is if we say print out my first list at the index of 4, and I know I shouldn't use a hard-coded number like 4, but I'm just doing that for an example, minus I. Okay? Technically, we'll fix that in just a second. So let's do this. Okay, so let's put in some words. Advantageous. Creatious. No, not creatious. Cretin. Hexagon. And flexible. Okay, so let's see what happens here. So the list is actually advantageous, Cretan, Cretaceous, hexagon, flexible. But if you look at what happened here, we printed out flexible, hexagon, we printed it out in reversed order. This last thing, right? So how do we get this to happen? So if you think about it, what we did is 4 minus 0, which is the first index to come out of here. 4 minus 0 is going to give us what? It's going to give us 4, which is the last index. So that should give us the last word, which, as it turns out, is flexible. And then the second word that's going to pop out is when you do 4 minus 1, so it's going to give us the thing at position 3, right? So here it's going to give us this, and then 4 minus 2 is going to give us the thing at position 2, and then 4 minus 1 is going to give us the thing at position 1. I'm sorry, 4 minus 3 is going to give us the thing at position 1, and then 4 minus 4 is going to give us the position at 0 thing. I am going to use the length of, well, I'm going to use the length of my word, yeah. Yeah. Yeah, that's right, basically. That's basically right. So what we're going to do, so this hard coding of 4 is kind of bad. And, well, yeah, so there is a way to do that, and I'll show you that in just a minute. Let me finish this one example right now, and then we'll talk a little bit more about range. Because range actually has some other arguments that are usually suppressed, but we'll talk about those in just a second. So, hard coding of 4 is kind of bad, and the reason why is maybe later on in your life, you'll change the list to be 6 elements, or 20, or 200, right? Nothing stops us. The only reason why this list has been 5 elements is because I have to enter 5 things. And I don't want to be entering 20 things. I don't want to be entering 200 things, right? The list can be 200 elements. The list can be 20 elements. So then you would notice, wait a second, that would invalidate all of these indices. Right, exactly. You would get negative indices or invalid indices. Things would not be exactly as you expect. You might have issues. Actually, I think it would work in Python, but it's not great. So in order to avoid that, what you're going to do is you can say, well, whatever the length of my first list is, just use that. But you notice that the length of my first list was actually 5, right? And I used 4, not 5. So we need an offset, right? And the reason why we need an offset is because we don't want to go 5, 4, 3, 2, 1, right? That's what it would do if it was counting this way. We want to go 4, 3, 2, 1, 0. And so in order to do that, what we can do is subtract 1. This 1 is okay, okay to hard code, because no matter what length of my first list is, the -1 is always correct, right? So that's why it's okay to code this one. It's probably bad to code like a 4 minus I directly into something like this, because you really don't want to force yourself to well, you don't want to force yourself to be restricted to the exact size of a certain list, because of course the first thing that happens is when you think, oh, a thing in programming will never change, right? It's like almost one of Murphy's laws. It's whenever you think that will never need to change, the next day, hour, minute, microsecond, either you or your boss says, change that, right? So that's, whenever you think something will never need to change, that's the moment when that you'll have to change it. So, anyway, so this will save us. Okay, so is there another way to reverse a list, to print out the list in reversed order? And the answer is yes, there's another way to do it. Well, yeah, so that's another good way to do it. But I'm actually going to use his question. I'm going to steal his question and use it to teach the other ways to do range. So let's say you want to start out at 1 and go to 100, not 0 to 99. So as the great and venerable TA Min was saying, you can say for x in range 100, you can print out x plus 1. And I'm going to teach you this now. There's a secret argument inside of print. And if you do end equals, and then you put in some string, what it does is it replaces the end line with whatever that string is. So let me show you an example of this. Tell me a word. Word 1, word 2, word 3, word 4. Okay. So you notice here that we have 1, 2, 3. So here we're just adding 1 to x. So that gets us 1, 2, 3, 4, 5 all the way up to 100. So that's fine, right? So we got 1 to 100 this way. So that's one way to do it. There's another way to do it. And for that, what we can do is we can say for x in range 1 to 101, like this. So the point is that if you have two arguments in range, we usually call them start and stop. The first one is where to start. Not surprising. The second one is where to stop, but of course with a less than sign, right? So remember that basically this thing is just saying start at x equals 1, go all the way up to 101, but go up to 101 with a less than sign on it, right? So it's not, so it's go while x is less than 101, right? So it's not less than or equal to, it's strictly less than. And so that's what this does. And so let's print out x with the end equals this. Yeah, non-inclusive is another way to say it. And of course you have to remember that the reason why it does all of this is because it wants to start off at index 0, because that's how lists work. Lists work with index 0, range works starting off at index 0, but you can force it to start off at another index by changing the start index like this. So let's see, the word is going to be palladium, tungsten, aluminum, or antimony, and Lawrencium. Okay, so did we get it? Well, oh crap, I forgot to. So if you ever need to do something where you need an extra print statement, here's how to do it. You literally just do print with nothing in it. So print with nothing in it will end with an end line, so let's do it this way. Let's come up with 5 more elements: hydrogen, boron, carbon, nitrogen, and copper. Okay, so you see that here's 2 ways to do the same thing. You can either start at the index 0 and go up to 100 and just add 1 to the index, or alternatively, you can start at 1 and go up to 101 like that. So for instance, let's do some other things where we can, let's say start equals int input, tell me where to start, and stop equals int input, so let's copy paste, tell me where to stop. And so now let's just do a few examples. So let's say while start is, oh no, actually let's say while start is not equal to -1. And don't worry about this is a different type of loop, but I'm just doing it. So end equals, as I explained, end equals, and then there's a string here. It'll replace that end line that comes after every print statement with whatever this end is. So it won't end your print statements with a new line. It'll end your print statements with a space, because that's what I put here. You could also do ASDF, and that would be stupid, right? You could put A in there, or you can put whatever you want in there. So let's say for T in range start stop. And so we'll print out T, right? Just to get a feel for what's going on here. So let's see what happens. What's some words? Some. Of course, I'm probably misspelling something. Oh, wonderful. I am stupid. Okay. Start equals 1. Okay, we're just doing ASDF because I'm bored. All right, so here's an example where you use end equals. Here's an example where you use end equals A. So you're going to get 1A, 2A, 3A, 4A, 5A, 6A, all the way up to 100 with an A at the end, right? And the reason is because it's replaced instead of doing an end line at the end of every print statement, it just puts an A for no reason. So that's how end is working there. So let's say where to start. Let's say that we start at 20 and we go up to 30. Let's see what happens. So here it's doing this for loop. Basically, it's basically doing this, right? It's going from start to stop. So it's going to go up from 20 to 29, because remember it goes up to 30 but does not include 30. So let's say it starts at -5 and goes to 100. What about this? So here you see that it's okay to start at negative numbers in the range object. It doesn't really care. It's happy to go up to 100. Of course, it doesn't include 100. So let's say that we go from -2, just to see it a little better, to 2. So you see here, it goes -2, -1, 0, and 1. It does not include 2. In order to include 2, you would have to do -2 up to 3, like this, to get kind of a symmetric interval. Okay, so what else do we do? What if we put in a start that's after the stop? So let's put in a start of 100 and a stop of 2, right? Is it going to go backwards, right? That's our first question. Tell me where to start. Let's try that again. 100, 2. What happened? It didn't print out anything, right? So what did we learn? Crap. What did we learn? Right, what did we learn on the show tonight? So what we learned is that if you have start that's after stop, so if start is bigger than stop, it won't do anything, right? It's just going to skip this loop. And the reason is because it's we would call it like an invalid range object, right? It's saying that you want to start at 100 and you want to go up to 2. But the problem is you can't do that, so in the end it just doesn't execute. Okay, so you can start at negatives. Okay, wow. Negatives. There we are. You can end at negatives, so that's all okay. You just want to be careful with list indices, obviously, but let's see what happens. So we can start at, say, -20, whoops, and we can go to -10, and so you see this will go, but then if you enter them backwards, if you say start at -10 and go to -20, nothing again, right? So that's basically how the range object works. The range object will basically say there's nothing in there, and so when the for loop says, get me the first thing in this range object, it'll say, give me the first thing. The range object says, you're done. And so it'll pop you out of the loop. Okay. So we've gone over the start and the stop argument. There's actually another secret argument inside of this thing, and it's called step. So step is, let's see, how many to step. So what if we do this? Now there are 3 arguments. So let's see what happens. So what is step going to do? Okay. So tell me what. Oops, stupid. Shouldn't have hit enter. Okay, so where do we start? Let's start at 0. Let's go up to 10, and let's step by 2. So let's see what happens if we do that. So here we're starting at 0, we're going up to 10, and it steps by 2. So here you see, yeah, it does skip certain values. So what it's going to do is it's going to go 0, 2, 4, 6, 8. So basically the point about step is that step is secretly equal to 1 unless you set it different. Okay? So start is equal to 0. Stop, you have to set. You can't not set stop. So stop is can't avoid this one. But start, it's default set to 0. Step is default set to 1, which is why in all the previous loops that we've done, we've counted by 1, is because we've secretly had the step set to 1. So you might be able to think like, oh, okay. So let's do from, say, 0 up to 20, stepping by, say, 7. So the first thing that should pop out is 0, then 7, then 14, like this. So what if I do 0, 21, and 7? So is 21 going to print out? And the answer is, let's see, no. And why does 21 not print out? Right? Because even with all these additional arguments, The fact is that the range object still has a less than sign on stop, basically, right? And so it does not include 21, even if by stepping up to it, you hit it exactly, right? So, for instance, if we say 0 up to 23 step by 7, it will print out 21, but it's not going to print out like 22, 23, because here it's saying, okay, we're going from 0, we add on 7, we add on 7, we add on 7. We add on another 7, we get 28, right? So that's bigger than 23, so it's not going to like print out 22 or print out 23 or anything like that. Alright, and so here is the other way to reverse a list, right? This whole lecture has basically been a big attempt at reversing a list. And so here is how to reverse a list. Here's my hint. So what if we start at 10, we go down to 0, and then, now that wasn't working with step size equals 1, because 10 plus 1, 10 plus 2, 10 plus 3 is never going to equal 0. But what if I put in -1? Can I do that? Let's see. Yeah, exactly. So look at this, right? So if I do 5, let's say I start at 4, we go to 0, or let's stop at -1 and step by -1. Yep, that's right, step -1. So, interesting, right? So we can actually go backwards as long as we're willing to use a negative step size. Now, if we use a negative step size, let's say we try to go from 0 up to 20 and step size by -1, that also won't work, right? Because this is in the correct order, right? This is going 0 up to 20. You cannot get up to 20 by subtraction, so it won't let you do it. So, as it turns out, it's a little more specific than that if start is bigger than stop. What it means is that if stop minus start is the same sign as step, then it'll work. Right? So if stop minus start is the same sign as step, so what that means is if the stop is after start, then this is positive, so you need to have a positive step. If the stop is less than start, then this will be negative, and you have to have a negative step. So that's what it really means. Does this work with strings too? Well, it's about to, right? It's about to. All right, so let's skip this stuff. And now let's input another word. Tell me yet another word. And then let me show you how to reverse a word. So for C in my word, print C. So this is going to print it out forwards, right? This is the easy way to print it out forwards. But how do I print it out in reverse? Now, there's other ways to do this in Python, but we're going to talk about how to do this using start, stop, and step in the range object. So what we're going to do is we're going to say for, say, I in range len my word, like this. And what we're going to do is we're going to, oh wait, no, I'm sorry. We want to do it with the range object. So we're going to start at the range, at the length of my word, -1. We're going to go down to -1, and we're going to step by -1. So let me show you what's happening here. So yeah, let's do this. Let's run this program. So this is, okay. Tell me yet another word. The word is going to be arbitrary. Okay. So let's see what happens. Oh Lord. Okay, I'm stupid. So the first thing that happened is that it printed it out in forward order, because that's what this is going to print this out in forward order. And that's because a string can be output using a for loop. Yeah, so I didn't bother to change this. So this was dumb. So if I print out I, we're just going to get indices, right? I is just going to be indices. we want to access the element at that index, and the way we access that element is doing my word subscript I, or my word brackets I. Okay, so let's do this again. Let me actually prevent all of this other code from running too. Tell me yet another word. The word is going to be excerpt, or whatever. Is that how to spell it? Maybe I'm wrong. Here we go. So here it is printed out in the forward direction, so that's what this is doing. And then here you'll notice it's printing it out in the reverse direction. So let's actually put end in here. So let's say that we want, let's put in another word. Seed. So here, it prints it out in forward order. Every time it hits a print statement, it puts a space, so that's why it puts the spaces in here. And then here, it prints it out in reverse order. So let's think about this for a second. Why do we need all these like -1s, right? What's each one of them doing, right? So why do we need the -1? Characters of the word. How do you specify if you want the for loop to address the characters of the words individually in the list? That's with the bracket notation, right? Right, so my word is a string, and if you do my word I, then that gets the character at I. So, okay. Right, so why do we need all these -1s? So the first, let's look at the start index and ask ourselves, why did we need this one, right? What's with this one? And the answer is because remember that if we have a word, let's just, for instance, let's do a word that is word, right? This is at index 0, this is at index 1, this is at index 2, and this is at index 3. So if we just stuck in the length of the word, because the length of the word is 4, right? So the length of, say, word is 4, but the last index is 3, so we have to shift down by 1. Okay, so that's one thing we have to do. Okay, so now what's with this other -1 in the stop? So why is -1 is equal to stop? Why is that? The answer is, remember that stop never gets hit. And so if we use 0, but what if you're, well, so here we don't have a list. Here we just are using a single string. But I'll do an example of that. So we'll do an example of that in just a second. So remember that stop never gets hit. If we use 0, then it's not going to hit 0. And we know that 0 is an index, so we need to do that. Okay, and then finally step is equal to -1 because we're going backwards. Okay, so a question was asked, like, what if we have a list of words? So let's make a list of words. So let's have a list of words be like 4, 4th, 40. Oh no, this is stupid. I want them to be very different so that we can see what's going on. So 4, score 7 years ago. Okay, so so here's a list of words. So if we just do for word in list of words, right, then we're just going to be getting, if we print out, for instance, word, we're just going to be getting the words. Would it work if you wrote len? No. Yes. In that case, yes. Yeah, you could shift the index too. That would also work. So you could also do range len my word 0 minus 1, but then you'd have to use I minus 1. Yep, you could do that too. So this is how you access each word in the list of words, right? And so, but what if you want to access the characters in each word? So here's how to do that. So if you want to access, say, the third character, or say the second character in each word, if we want to print out the character in each word, we can actually do this, or let's actually use indices for both. So for I in range len list of words, so we'll print out list of words I here. And then here what we're going to do is we're going to say for j in range len list of words I, and then we can actually print out list of words I, j. So what this does is it actually gets the ith word and the jth letter in that word and prints it. So let's put end equals like a colon or something. That way we'll see what's going on. So here we go. Interesting. Print list of words I for j. Oh, because this is printing with an end line. Okay, that's really confusing. Let's just redo this. That is really confusing. Okay. So here, if you want to access, if you have a bunch of strings in a list, and you want to access the characters in a particular string, then you'll have to use a separate index. So so I index is the position in the list. J index is the position in the ith string, and so that's that. So I'm going to talk a little bit more about nesting loops later. This is what's called nesting loops. So we can nest if statements, and here we nested loops. So for instance, if you want to nest a loop like this, like an end, yeah. So one of the most common things to do, like I think one of the most common things to do with nested loops is if you want to draw a grid. So if you say like x is equal to, or say y is equal, or even better, let's just use width. And height equals, what is the height? And so then we can say for x in range width, for y in range height, and we can print out, say, a star, and then print out an end line. And so if we notice what this is going to do, we'll say, okay, so let's say ASDF. Okay, so what is the width? The width, let's say it's 10, and let's say the height is 5. Okay, didn't put end in. And so notice here I used end equals empty string, not space. So let's try it again. The width is 5, the height is going to be 3. So add them backwards. Cool. There we go. So let's try it one last time. The width is going to be 10, the height is going to be 5, and let's hope this does it. There we go. So we see that there's 1, 2, 3, 4, 5 stacks, I guess, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 stars in each line. So basically, like this is a general way to draw grids. And there's going to be a homework problem that's very similar to this in the future. Okay. So I haven't talked a lot about lists. I've kind of used lists of strings, but I haven't really discussed a lot about lists. So let me talk about lists a bit. So lists don't have to be of strings. Lists can be of any type. So for instance, you can have another list, which is equal to, say, 1, 2, 4, 8, 12, right? That's integers. You can have float list, which is, say, 2.1, 3.2, 4.3, 5.4, something like that. You can have a list of floats. Obviously, you know you can have string list, right? Something like that. You can even have a bool list, right? Like true, false, false, true, true, false, true. And so that's a good question. Do they have to all be of the same type? And the answer is actually no. So do the elements have to be of the same type? No. But it is recommended. So it isn't recommended as in, like, you know, do this if everything else, you know, if your solution really makes sense with this. But the reason why, so here's a mixed list, right, of a whole bunch of mixed types. 1, hello, 3.14, false, true. And it can even contain other lists, so like 2, 45, 98, happy. It can contain false, you know, 3. So all of this is fine, right? So none of this is a problem. Tell me yet another word. Yet. Okay, what is the width? 2, height 2. So cool. So you see, well, we haven't printed any of this out. But what have we done? At least all of these lists were declared, and you see that the process finished with exit code 0. And so what that means is it didn't crash. But here's the reason why you don't actually do this very often. Basically, if you say 4x in mixed list, right, and you say, oh, I think that the things in there are addable, right? So I say print x plus 2, right? Then here's the problem. Let's say 6 and 6. So here's the problem. What's going to happen is that the first thing is going to work, right? Because 1 plus 2 is fine. And then it's going to try to add 2 to hello. And then you see here you get a type error because it says you can only concatenate string, not int. It thinks that this plus sign is string concatenation. If you did a 2 plus hello, it'd probably be like cannot add string to int kind of thing, and so it would think it was an int addition that you were trying to add a string to. So it's totally possible to use mixed types inside of a list. It's not always a bad idea, but the reason why I'm saying that this is not recommended is just because generally you want everything in your lists to be the same thing so that you can operate on each element in the same way, right? Like if you're printing out strings, you want everything to be a string. If you're adding up numbers, if you're doing some kind of calculation, you want them all to at least be ints or floats. I mean, you can mix ints and floats together, and that's probably not an issue. But you don't want them to be strings with ints, with floats, with bools, with other lists. You don't want that. And the reason why you don't want that is because as soon as you hit something that isn't the right type, then your program will crash. So, if you have an enter float with more than one digit, can you get that specific digit using the same? Sadly, no. Sadly, no. So, if you want to get a specific digit, so, like, let's say that we have a number. Let's say that we have the number 1729, and we want the thing in the hundreds place, right? We want the 7 for some reason. So here's how I would get it. What I would do is I would take n, I would integer divide by, say, 100. Yeah, you're about to see mod. And then I would mod it with 10. So, and so what is this doing? What this is doing is it's taking n, it's dividing it by 100, so we'll get 17. It truncates the 29 off, because this is integer division. And then we have 17, but we don't want the 1, so we just mod by 10 to get that digit. So let's print out hundreds digit. Oh, crap. No, we don't. That will never happen, so this is bad. Okay. Gotta rerun it. Okay, so what is the width? 17. 17. Okay, so that's a big blob. But you see here that this is how you would isolate a digit. Basically, the reason why we do this, and you will end up having to do something like this. This is definitely a very useful thing. I just haven't gone over it yet. Especially when we do conversions between, say, binary, hexadecimal, all the, I guess I'm not going to talk about octal, but binary, hexadecimal, and decimal. So when we go over those conversions, this is actually a really useful trick, and we're going to use this trick a bunch of times in the future. But yeah, unfortunately, you cannot just go n sub 2 to get the hundreds place. Wouldn't that be nice, right? So, but anyway, okay, so I think that's all for today, because I think we've talked a little bit about for loops. I think the important thing with for loops is just to go and practice, right? You could make it a string. Yes, you could. So you are pointing out that you could actually do string of n, and then you could do eat the 2 thing, and then you could do int of that, and you could say print this, and that would probably, I think that would work. Let's see if that works. 5, 5. Oh, I'm sorry. So you would have to know how many digits there were in the thing, because this is 0, this is 1, so we'd have to take the thing in the first position. So, blah. So it does work, but you notice that you have to know some extra stuff to make this trick work. Yeah, you would have to use length. There's a bunch of you can. So as yes, you can do all of those things. I guess you could always say, like length of stir n. What is it? If we think about it, it'd be the thing in the third to the last position. So that'll work. So if this isn't tricky enough, then you're too tricky, right? So this is not something that we're going to expect you to like just come up with. This is the fact that like you. I guess this is sort of an after class observation about Python. And about a lot of programming languages, but about Python specifically. Python allows you to do a huge amount of things, right? Some are good, some are bad, some are weird. Okay, and so that's the, this is probably in the somewhere between bad and weird category. But it doesn't mean it's not possible, right? So there's all, you can write code that's good, you can write code that's bad, you can write something like this that's just just freaking weird, right? And that's totally possible. As you see, it worked. But it's just one of those things that you want to be a little careful about. So, okay. All right. Anyway, yeah, so basically the way that we teach this course is we try to teach we try our best to teach things that are mostly good. And we try to teach you to avoid some of the bad, and then we send you off to write your homeworks, and what we get back is mostly weird. So I guess there's some nice duality or triality or something like that. Okay, I think that's it. I think we've, this is not like the test of your understanding. So this is something I think that students should be able to understand. This is something that I think is a little bit different. Okay, I'll let everybody go now. Thanks, everyone. We'll talk more about for loops and lists next time. We're basically going to spend 3 days on for loops and lists because for loops are like such a critical, integral part of almost every programming language. They are the loop that you go to in almost all cases. Like 1 out of every 20 times use a while loop. But most of the time you're going to use a for loop, and so I want you to be comfortable with them, I want you to be good at them, I want you to know what you're doing with them, and I want you to like them. Alright, so that's it for me. I'm going to play the outro now, if I can find OBS. Here it is. Goodbye.